Hello everyone. So I'll be doing a short video on Git. I'll just demonstrate how to clone a Git repository, make an update to the code, and push the updates back to the remote repository. So everything which I taught in my Git session, my free Git session yesterday, I'll demonstrate that very quickly with a project which one of my learners has shared. So he has a problem with his code. He has shared the code via Git. So I'll clone his project, double check if everything is okay in his project. And if I find an error, I'll update the code and push the updated code back to his remote repository. So let's get started. While we wait for him, he's supposed to join me in the meeting. So while we wait for him, let's get started. So I'll share my screen. I hope you can see my screen. So this is my GitHub repository, and he sent me a request. So let's check. So let's check if we can find the request. This is the request he sent for me to join his project. So I'll accept his invitation. And so this is his project with all his files. So he's trying to predict the selling prices of houses. So this is all the code. So I'll try to clone his project. Again, to clone his project, I need to go to the URL for his GitHub account. So I'll go there, copy that, and again I'll open the GitHub. Let's do git command. So we're using the command line. So we have this as the command line. Let's see where we can clone his account. So let's go to my computer and let's look for a location in my computer where we can clone his account. So I'll go to my documents and I'll put, yeah, so let's go back. So I'll just do that in the Git demo folder. Yeah, so I'll do that in the Git demo folder. I'll copy that and I'll change my location, my Git, so that I point to that folder, and that is where I'll copy the the folder from the remote repository to my local repository. So I'll clone the remote repository in this location in my local computer. So let's go back again and let's copy the URL. So do a git clone. I'll put the URL which we want to clone, put enter, and we're cloning that repository. And so we have that repository. If I go back to my URL folder, you see in my local computer, I now have a version of his code on my local computer. So that is the distributed version control. So there is a version of this project in the remote repository and another version in my local computer. So you can see all the files, all his code and his data files, all of them are found in this folder. So the first thing I will do is I will I'll branch out from this main folder. So let me branch out so that I can experiment on what he has done. So first of all, let me go to the folder. So I'll do a change directory. I'll go into the folder where the code is found. So the code is found in the housing prices folder. So while here, I'll first check which branches I currently have for this folder. And I see that in my local computer, I have just one branch called the main, which obviously holds the code of which all of the code and data which I have cloned from the remote repository. So the first thing I'll do is I'll branch out of this main folder. I'll create a branch. So I'll do a git checkout. I'll create a branch called, let's call it solve, let's call it solve house prices. HP, let's call it solve HP, which means solve housing prices code. Solve HP code. So I'll branch out. If I do a git checkout, sorry, I'll do a git branch to see the branch I am currently on. And you see I am now currently, so I've created a new branch. Again, what is a branch? Is just another folder within my local repository, but I cannot see this folder here because it's managed by Git. So Git manages these different branches. You cannot see it visually, but you can switch between these different branches, which are simply just folders that contain different files which you are working on. So currently I am working on the solve HP code folder or branch, which is managed by Git on my local computer. So I can verify that because I see Git branch, I see that I am in that branch solve HP code. So that's fine. So now I want to check his code and see if there's any issue. If there's any issue, I'll resolve it, and I'll send the updated code back to his remote repository. So let me open, I usually use Visual Studio Code for my programming. So I'll open Visual Studio Code. Here is Visual Studio Code, and I'll open the folder which has the code. So I'll go to Drive C, Users, and I'll go to Documents, and I'll go to Git Demo, and we are dealing with the housing prices. So I've opened that folder which has my learner's code, and I can see his code, and I'll put yes, trusted. So the first thing about his code is I want to check is his housing price cleaning pipeline. So this is his housing his housing price clean his house price cleaning pipeline to clean his data set. So let's see the pipeline. It has everything needed to clean his data set. So it would first identify inconsistencies in his data. He would standardize, he will clean his data. He will standardize categories, which is handling the inconsistencies within his data. And let me see what he does in standardized categories and handle inconsistencies. So in standardized categories, he will check for all categorical features, and he will ensure that he will change all categorical features to uppercase, and he will strip any extra spaces in the categorical features, and he will return the data frame. And let's see what he does with handle inconsistencies. For handle inconsistencies, this function will handle inconsistencies in the categories. So currently we see that actually he doesn't handle any inconsistencies here. So let's first solve the spacing problem. So I've updated this spacing problem. So what he will do here, he will take for every feature, every column in his data frame, he will check he will check the unique values of that column. So let's put that there. So for every column, he will check the unique values of that column. So he actually does not handle any inconsistency in this function. So the name of the function may be misleading. So let's call it check inconsistencies, because he will actually be checking for inconsistencies. So it's similar. If you look at the functionality, what he does in identify inconsistencies is very similar to what he does here. So let's remove this function altogether, because it's the same thing which he would do, which he does. So he would check for inconsistencies. So let's call it check inconsistencies for each column He will check the unique values of that column, and he will handle the inconsistencies here. So so checking inconsistencies, yeah, he will return the data frame and he will handle the inconsistencies here, which is good. So let's go down back to his pipeline. So let's call this check inconsistencies. So he will check for inconsistencies. He will return a data frame. So he will take housing prices. He will return a data frame called housing prices. And because the check inconsistency function actually returns a data frame, so it returns a data frame, so he will return that data frame which he has created. To standardize the categories, he will take for all categorical features, so all columns which are categorical, he will change all of their values to an uppercase and remove any leading spaces, which is good. So that is how he will handle his inconsistencies or standardize the categories. And he will return the new standardized data frame, which is good. So we will come here and we will say, okay, standardized categories is perfect. We do not have anything called handle inconsistencies anymore. So anyway, to make it easy, better, let's put check inconsistencies. So he will check for inconsistencies, handle inconsistencies, and after he handles inconsistencies, he will check just to double check that all the inconsistencies have been handled. So in the check inconsistency, we will not return any data frame. Yep, so this is perfect. So now that is correct. We go now to check and handle missing values. He will check for missing values. Let's see how he checks for missing values. So he will check for missing values. He will impute missing values. So where there is a missing value for a categorical feature, he will impute it with an unknown category. And where there is a missing value for a numerical feature, he will impute it with -1. So this is correct. So check for missing values and impute missing values is correct. Then we go now to checking for duplicate columns. So he will check for duplicate columns. And if there are any duplicate columns, so we check for duplicate columns. If there are any duplicate columns, he will drop that the duplicate columns. So let's look at the check for duplicate columns. It's always good to put a print statement here to actually tell us that we'll be checking for duplicate columns, similar to checking for missing values, checking for inconsistencies, just to ensure so that when we are running the pipeline, these print statements will tell us what is happening. So it will check for duplicate columns. If it finds duplicate columns, we want it to print the duplicate columns. So let's put another print statement before. So duplicate columns, he will print out all of the duplicate columns which have been found before we return those duplicate columns. Similar, we'll check for duplicate rows in the data, and the number of duplicate rows will return the number of duplicate rows, and we will check for partial duplicates in the data. So the number of partial duplicate rows, so we'll check for partial duplicate rows in the data. So let's put partial duplicate rows in the data. And that's perfect. Then we will detect outliers, and we can check if there are outliers. So columns with outliers, we can check for outliers. We will just check for outliers. We will not actually handle outliers, as well as highly correlated features. We'll check for highly correlated features. However, we will not handle the highly correlated features. So let's go here. So we checked for Duplicate columns, he cleaned the duplicate columns, checked for duplicate rows, cleaned the duplicate rows. He checked for partial duplicates, cleaned the partial duplicates. And actually, let's check for, let's just check for outliers. We will not handle the outliers. And again, let's check for, let's identify highly correlated features, but we will not handle the highly correlated features. So our pipeline is perfect. And let's look at, he added, does he have the housing price data set over here? So this he passed to get the cleaned housing price data set. So let's look at his cleaned housing price data set. Okay, so we have cleaned his pipeline for his housing prices. So this is fine. So let's move now to his machine learning his modeling pipeline. So this is his housing, cleaning of his housing price and his housing price modeling pipeline. So again, to model the data, he has the binary columns, which is good, which he will do binary encoding. He has identified the nominal columns, which he will do one-hot encoding. So this is his modeling pipeline for his test set. So let's check his modeling pipeline for his training data set. So I guess this is his modeling pipeline for his training data set. So this is okay. So we have his modeling pipeline for his training data set. He will import the clean data. Let's import this data. So he has imported, I've imported the clean data set, which he cleaned using his housing price cleaning pipeline. Let's look at the data. So he has his different columns and he has his output sale price, data types. Again, he has all of his data types. The sale price ends with an integer and everything. He has objects, he has floats, and he has integers, which is good. So the first thing is to, in his modeling pipeline, is to encode his categorical data. Let's see what the learner does. He identifies his categorical features. So identify columns which are categorical. Yes, he does that, and he can identify. If you look at the categorical features, he has just two types of categories. He has binary categories, which have just two values, and he has nominal categories, which have multiple, which there is no order between the categories. So he has streets with two values and that. So he identifies his binary columns. So his binary columns are street, utilities, because they have just two values, and central air. He identifies his nominal columns. His nominal columns are the remainder of the columns. So he's good. He wants to encode his binary columns. So a binary column, he replaces, encoding means you are replacing the categories with numerical values. So he replaces all of his binary columns with numerical values. So this is perfect. In this, one thing I'll even encourage him to add in his encoding of his binary columns is to add an unknown. So maybe add an unknown category. Obviously, he doesn't have, there is no unknown, but just in case a new data comes in and there is actually an unknown category. So he wants to add unknown. So let's put unknown as -1, and let's put unknown as -1. So it's still categorical, but we're just ensuring that if anyone comes with a missing categorical value, you can still capture that within your pipeline. So this is the first thing he would do. So we have added that, and print. So he's printing to ensure that what he has done is valid. So you see now the street, he doesn't have, before he had street with pave and GRVL, but now his street categories have been changed to 1 and 0. So he has encoded them to numerical values, which is good. So he does not need to change it to integers. So there is no need to change this to an integer. So 1 and 0 is okay. So he wants now to encode his nominal features. So we're just checking so that you see how now he has 21 features. After he encodes the nominal features, you're going to see that the number of features he has will increase significantly, because when you do one hot encoding, you actually change each category to each category in the nominal feature to a new feature. So if you have yes and no as a category, you now have yes as a new feature and no as a new feature, and you're going to see that. So these are his nominal columns. So we'll be using the one hot encoded functionality from scikit-learn to actually one hot encode these features. So this is what it does. It will fit on the nominal columns and transform the nominal columns to an array. And he will save this as a one hot encoded pickle file. He will add this to, obviously his data frame is data. He will create a data frame with the encoded features, where the index is the data, which is good. So he will create a data frame with the one hot encoded features. He would drop the nominal features and add the one hot encoded features to his data. This is correct. So let's see what it does. So now if we print now, if you print the head of his data, so if you put data dot head, you now see that his nominal features, he had M zoning all is now a column. Before, the M zoning had categories. If you look at the M zoning, it had categories RL, RMC, or FV, and so on. But all of these now become columns. So if you look at it, you have an M zone all column. And if a house has this M zone all category, it will have 1. If it did not have this category, it will have 0. So he has changed all of this into columns. And we still have up to our electrical, sorry, I'm here, up to our sale price. So he has still maintained all of this up to the sale price, which is perfect. And now what he does is, this is not needed anymore. So you can check his columns now. So he has this amount of columns. If you look at the shape, he will no longer have 21 columns, but he has increased, the number of columns have increased. And he will check if he has any object in his data. All of his categorical features have been changed to numerical features, which is perfect. So he is perfect. He saved this as a modeled price data. So let's save this as a model price data. And now he splits his data into a training and test set. So he's moving now to machine learning. He wants to train his machine learning model. So he splits his data into a training and test set. So let him split here, split into the output and the input columns. So he does the train test split. and he splits his data into a train test split, input, input, output, output, and he does two. He shuffles the input outputs, and he does a random. This is perfect. We had the input and he had the output. So he has split this into his train test split for his machine learning. And obviously, yeah, he resets his index. If he resets the index of the input, he has to actually reset the index also of his output, which is good. He also output values. If he resets the index of his test, he has to also reset the index of his test output, which is good. And now he performs scaling. So he's doing min max scaling. He's fitting the scaling factor on his input and using that to transform on his training set and using that to transform his test set, which is good. And he saves his min max scalar functionality again, which is good. So he has dumped that. But now his training set and his test sets are just arrays. So he transforms them back into a data frame, which is good. And he has this. So he has his training set and he has his test set. And now he can train his machine learning model. So training his machine learning model, he does not need this. We do not need this again because he has his training, his input and output. So he has all what he needs to train his machine learning model. So he does not need this, does not need this. So he wants to build a simple decision tree model. Does not need this, does not need this. So he will not do feature selection. He will use the entire data to train his model. So his training data, again, he split his data into his output. So we have the input train, we have the output train. So now he's training, he wants to build his machine learning model, which is good. This is the metrics he will use to evaluate his machine learning model. He will use mean absolute error, root mean squared error, and his R squared to evaluate his machine learning model. He may plot a plot, so he may do some visualization. So he will use the matplotlib as well. And he'll be using the linear. So he started with a linear regression model. So let's train a simple linear regression model. That is good. So he has his linear regression model. He trains the linear regression model. So he passes the input, which is and the output of his training data. And he makes predictions on his linear regression model. And he evaluates his linear regression model. He evaluates it both on the training data set and on the test data set, and he produces the evaluation performance. And looking at the evaluation performance, his root mean squared error is quite good on his training data set, but it's quite poor on his test data set. That means the data is overfitting on his training data set. And when he tries to plot the prediction against the actual, okay, let's ignore this. And let's go down to where he builds now a decision tree. So the linear regression model was not good at capturing the underlying pattern. It overfitted on the training data set. So he tries now to use a little bit a more complex model, which is a decision tree regressor. He fits that on his input and output data. Again, he evaluates his model, and the model he checks his performance, and you now see the root mean squared error is much better. It's still overfitting on the training data because we still see a very we still see a very low error for the training data and a high error for the test data. So it's still overfitting on his training data. I think he plotted the regression. We see some outliers here. So we see this may be affecting the model, but you see it's getting there, but it's actually overfitting on his training data set. So you can see that the training data set performance is perfect, but the test performance is still quite high. So it's still overfitting on his training data set. So he goes further and now he tries a random forest model to improve this performance, which is an ensemble of multiple decision trees. So he does that. And now his performance is quite good. So his training error is still low, but now at least it's closer to his test error and his performance is quite high. And so his random forest model is much better than his decision tree and his linear regression model. And he can also double check the regression line. And you see that point which was far in the decision tree gets closer to the prediction line, which is really good. And now he can save his model. So he can do feature importance. I think he's checking which features are driving the outcome. So he checks which features are driving the outcome. And he sees that houses that have garages have a higher influence on the selling price of the house. The year which the house was built also has a high influence on the selling price of the house. The total number of base rooms in the basement, the total number of full bathrooms. So these are the top 10 features that have a high influence on the selling prices of houses, which is good. So he can use this to inform decisions on how to build houses to ensure that the houses can be sold at good prices. So he does that. And lastly, he also does a grid search. We will ignore that. And let us save his model. So after he has done this, let's add a point to save his model. So before he does the grid search, let's save his model. So let's save the model to a file. So he has his random forest model. We'll save it as housing price random forest model. Let's save that. Let's run that. So his model, we have saved the model which he used, the random forest model, because it was the best performing compared to the other models. So we have saved that model using the picker. We have dumped it to a picker file, which is good. And we will now move forward to his testing of new data. So he wants to use the model he has trained to test to try to predict the housing price of new data. So let's see what he does. So this is where he's trying to, he's doing a prediction testing. So again, we saved the model called, what was the model? Housing price random forest. So let's copy that name of that model. Let's go back to the code. So let's load that model which we saved. So housing price random forest model. Let's load it into the model. So we are loading that model. So there's not, okay, sorry, picker. One second, sorry. So he has loaded that model. and he has the data. He has new houses have come to his company, and now he wants to be able to predict the housing prices of those new houses. So let's look at his data. So he has data for he has data that's coming. So he has new data. So let's see the new data that has come in. So this is a new, so new data has come in. He has his M zoning. So he has, so how many? This is about 15 houses. So new data is coming for 15 houses, and he would like to predict the selling price of these new 15 houses that have come in, new data for these 15 houses. So that is what we are trying to do using the model we have trained. So he wants to predict the selling price of these 15 houses. So we call this the new data. So we load the new data, and we have the new data here, which is the new 15 houses. Convert the name to index. He does not need to do this because the M zoning is a column, so he does not need to do it. And I think this is where he's getting his error. This is where he has been facing the error, because he has transformed this to the index. You do not do this because it's part of the column. So you don't need to transform the MS zoning to an index. So Lionel, hello?
Yes,
Hello?
bro.
Yeah, so I've seen the error in your code.
Okay.
Yes, the error was here. So when you got the new data, you transformed the M zoning to an index. You were not supposed to do that. I
So
know
I said the index.
I know you did that because you saw in my testing example, which I demonstrated during the course, I transformed the name of I was doing the name of students into an index.
Yes.
I did that because the name of student was not a column in the data that was used to train the machine learning model. Does that
Okay.
make
Okay.
sense? Yeah, it wasn't a column that was used to train the machine learning model. So that is why I transformed that name into an index. But yours, your M zoning is a column that is used within, it's one of the main columns that you have used to train your machine learning model. So you do not need to transform this M zoning to an index, else you will not be able to test. Your data will be lacking the M zoning column when you are trying to either clean the data or model the data. You will not have this M zoning column. So this is where the error is. So I'll comment out this. So when you load your new data, this is your new data. You import the clean housing price cleaning pipeline. So let's look at the housing price cleaning pipeline. This is it. So you imported it as HPP. There was an error. No such file as housing. Okay, so did you create a new one for that? So let's go to the housing price cleaning pipeline. So in the housing price cleaning pipeline, we do not want this. So we'll comment out this. And we will not be using the handle partial duplicates for the new data, because obviously we want to keep the columns. We want to keep all the rows because it's new data. So we do not want to, even if the rows repeat themselves, we still want to predict the housing prices for the rows. So we will not check for duplicate values, duplicate rows, and we will not check for partial duplicate. We will not check for duplicate rows, and we will not check for partial duplicate rows. We will also not handle duplicate columns because it wasn't handled in the training data. So we will not handle duplicate columns. Obviously, we'll handle missing values and we will handle inconsistencies. So these are the only two things we'll handle for incoming data. For our new data set, we'll only handle missing values and inconsistencies. So we'll save this. And we will import this into our data. So we have imported that. We will clean our new data. We have cleaned our new data. We have cleaned our new data. We'll check our new cleaned data, and it has the values that we want. We will ignore that. We want to do the modeling. So let me check the housing price modeling. I added a few things. The first thing I added in your binary encoding of your binary data is I added the unknown category. It's important to just keep that unknown category so that it handles if the data, if a house comes in and it doesn't have the street type or the street category or the utility categories, during the cleaning process, it will transform that street to an unknown, and you want to always handle that. So even though your data did not have any unknowns, it's always good as a good practice to add the unknown category. So if you go to your modeling price, yeah, I'll just add the unknown category. And I'll check again, binary, unknown, M zoning. And that's why you were getting an error, because M zoning was no longer a column, but the M zoning is, yeah, so you load the picker file, you will transform the data to an array, you will load the min max scalar, you transform the data using the min max scalar, and so this should be okay. So let's save this and let's load this pipeline. So where are we? Yeah. So okay, we are right down, sorry. So we are here. So we want to encode, we want to model the data. Let's load it as, remember, you always want to just load it as a small data. Let's put model housing pipeline. So let's import that and let's model our data. So we'll call this new data modeled, and it will take the new data clean and it will do the modeling. Let's see what we had model data here. So let's use that same function and let's see if it models our data. And we have modeled our data and our new data modeled. Let's check the data. And our new data model is perfect. You see it has the one hot encoded columns, and it has, yes, it has everything you need. So now you can actually test, you can use your trained machine learning model to predict the housing prices for the new houses. I have a meeting now, so I'll just end because I'll push back this code. So I cloned this code from your repository. I've done the updates, so the code now works well. So I'll push back this code to your repository so that you can use the code later on. So, and that is the advantage of using Git. So I'll save this and we have everything saved. So what I will do now, we have now I have the latest update. We have updated the code. So what I'll do, I'll go now to Git and the first thing, because I'm now in this branch. So I created, when I cloned your data, I created a branch called solve HP, which is housing price code. So I branched out of the main because, as I said, it's not a good practice to always do your coding on the main branch. So I branched out of the main. I've updated your code. I've solved the problem. So I will first do a git add, which I'll add to the code to the staging area in the working. Okay, it's just giving me a warning, which is okay. Then I'll do a git commit. So I've added to a staging area. Now I'll commit the changes which I have done. I'll add a message, and the message is, what do we find? We found the M zoning index issue resolved. That was the main issue we found. So I'll save that. So this will save everything which I have done. It will save it to Git's memory. And now I'll push this code back to your repository so that you have this updated code now in the repository for you to use. You can now use the code. You can now, if you have not cloned the code yet, you can clone the code, do your testing, do everything, and keep updating your repository. So I'll push this back to your repository where the code I received was. So I'll do a git push to origin. Origin is the remote. So I'm pushing this updated code back to the remote repository. And what am I pushing? I'm pushing from my local branch called solve underscore HP underscore code to your remote branch. So let me check the branches you have in your remote. To check the branches in your remote repository, I do a git branch /r, and it tells me you have only one branch in your remote repository called your main. So I'll be pushing this directly to your main repository. So I'll do a git push origin. I'm pushing from my local solve branch, solve underscore HP underscore code to your main branch, and it's pushing. And there's a permission to git. Okay, I do not have you have not
Okay, you
given
give
me.
me the other details. You don't give me the master.
Yes, can you give me, are you, do you have access to the code now?
Yes, yes.
Do you have access? Yeah, so give access to Gmail. Let me see. So give access to Gmail. Let me go now and log in as Gmail. So I'm logging in as Gmail so that you can give me access for me to push the code. I'm logging in, doing my authentication. So I'm logging in. I'm checking if you have given me access. You have not
People
yet given.
connect me. Not yet. I'm still trying to
Okay.
do it.
So if you give me access, I'll be able to push this, and now you will have the latest version. And what you would do is, if this repository is already cloned in your local computer, what you do is that you pull this latest version back, because imagine you already had a version in your local computer. It will not have the updates I have done, right? Because the updates I have done is in the remote repository. So what you do is you pull the updates of what I have done to your local computer. You can now update the code and do your testing of the new test set. Clean up your code. When you clean up your code, you push back this updated version of your code back to the remote repository. And whenever, if you find a problem, you push back this code. I'll come now and I'll pull back the code and I'll resolve the problem. So everything you do, you push it back to the remote repository. And if you have a problem, you tell me, I'll come and pull what I have found in the remote repository. I'll resolve your problem and push it back to the remote repository so that you can do whatever you need to do. And that is all about Git. It's all about working on your local on your computer, doing all the updates, branching out and adding features, but pushing back these updates to the remote repository so that other developers can pull or fetch, either pull or fetch these latest updates, work on them, and push it back to the remote repository. And that's how the collaboration is done between the two developers. Have you been able to add me?
No, not yet. I'm still looking for where I leave it. How did I do this thing?
It's supposed, you have to go to settings.
Yes, settings, yes.
You go to settings. So if you, for example,
I've
I
seen
mean,
it. Yeah, I've seen it.
yes, you go to
I've seen
settings.
it.
So if I'm in DCT, for example, I will go to settings.
Okay, add people, Jim Marcel. Hold on. Jim Marcel. Okay, I hope it's this one.
Yeah, it's Jim Masse, just Jim Masse. So if I open this, if you look at this, so do you see it? It's Jim Masse.
Okay,
Just as it's said, Jimmase. So when you do that,
yeah, I'm adding now.
okay, I should have received it now. Let me see if I can refresh. So have you added it?
Yes, yes, I've added it.
Okay.
Refresh again one more time.
Luna.
Okay.
Still not received.
Still have the same up to now.
Okay, I've received it. Okay, sorry, you had to go to on. Okay, so I've accepted. So you see, I now have access. So I'll go now and just push the code. Repeat what I did. I'll push the code to the main, and I have pushed. It's pushing, and everything is updated. So if you now go, if we go
Wow.
back to the repository, and I refresh this, you will see that it's saying, you see the comment is telling me that 7 minutes ago these files were updated, and it's giving me
Yeah,
the
I've seen
name,
it. I've seen it.
yes, the name of the comment and the commit, which was zoning index issue resolved. So if you go now and you pull this
Yes,
code,
yes.
if you
I've
pull
seen the
this
new
code,
set of files.
yes, if you pull this code to your local computer, you can now test your prediction. So try this out and let me know how it goes. I have another meeting in 2 minutes. So let me know how it goes. And if you have any other issues, let me know.
Okay,
Okay.
okay, bro. No issue.
Okay.
Thank you.
Okay. Okay. Thank you so much and see you.